I've written over here the definition for the slope of a line. The slope of the line through the points x sub 1, y sub 1, and x sub 2, y sub 2 is given by this formula. M is the letter we usually use to represent slope. y2 subtract y1 divided by the quantity x2 subtract x1, and that's equal to the rise over the run. This is the algebraic definition for slope, and this is the geometric definition. So I have this ordered pair and this ordered pair. The slope of the line is the difference of the y-coordinates divided by the difference of the x-coordinates. And whatever direction I start subtracting in the numerator, I have to continue subtracting in that direction in the denominator. So if I start here with this y2 and subtract y1, then I have to take x2 subtract x1. I can do it in the reverse order also and start here and take this, subtract this, as long as I use this x, subtract this x also. Now rise over the run stands for the ratio of the vertical change to the horizontal change as I go from any one point on the line to another point on the line. So if this is the point x sub 1, y sub 1 right here, and this is the point x sub 2, y sub 2, then as I move from this point to this point, horizontally and vertically, the horizontal distance that I move is called the run in the graph, and of course that's going to be the difference of the x-coordinate of this point and this point, and the vertical distance that I move is going to be called the rise, and that of course is the difference of these y-coordinates. This y-coordinate subtract this y-coordinate. So the rise and the run in the graph, this geometric idea, does correspond to the difference of the y-coordinates and the difference of the x-coordinates. What I want to do now is take a couple of specific points and see if we can find the slope of the line that goes between them, and then actually look at the line that goes between them and see if we can identify that rise and run, and also see if it corresponds to what we get for the slope of the line. Let's take a look at our first example. I want to find the slope of the line that goes through the point 3, 1 and the point 5, 4. So what I'm going to do is assign this point coordinates x sub 1, y sub 1, and this point I'm going to assign coordinates x sub 2, y sub 2, so that I can use my formula m equals y2 minus y1 divided by x2 minus x1. So I'll take y2, which is 4, and subtract from it y1, which is 1. So I get 4 subtract 1 divided by x2, which is 5, subtract x1, which is 3. So 5 subtract 3. That gives me 3 in the numerator, and in the denominator I end up with 2. So I have a slope of 3/2. Now I want to show you also that I could subtract in the opposite order also. I could start here with this one and subtract 4. If I do that though, when I go to my x-coordinates, I have to start with the x-coordinate of the point the same that had the y-coordinate I started with, so it has to be 3 subtract 5. But if I do that, notice that I get negative 3 divided by negative 2, which is the same as 3/2. So it doesn't make any difference what order I subtract in, as long as whatever order I start subtracting in, I continue to subtract in that order. So if I start with this y and subtract this y, I have to start with this x and subtract this x. If I do it the other way around, this y minus this y, then I have to take this x minus this x. The difference of the y-coordinates is always in the numerator. The difference of the x-coordinates is always in the denominator. Now let's look at the line that goes through these 2 points. So first I'll graph the point x equal 3, y is equal to 1. That's this point right here. Then I'll graph the point x equal 5, y equal 4. So x is equal to 5, y is equal to 1, 2, 3, 4. That's this point. Now I want to draw a line between these 2 points. So that will look like this. And you can see that if I start at this point and go to this point, I'll have a horizontal change of positive 2, that is a run of positive 2, and then I'll have to go up positive 3 to get back to that point. Well, this is the rise in the graph, the vertical change. This is the run in the graph, the horizontal change. So I see that my ratio of rise to run is positive 3 over positive 2, which is also 3/2. Now, how about if I started at this point right here and I went down 3 units? That's a run of 3 units in the negative direction. When I go down, that's a run of negative 3. How do I get back to the graph? I'm sorry, when I go down, that's a rise of negative 3. Now, from that point, that place, how do I get back to the graph? I have to go back 2 units. That's a run of negative 2. So in this case, the ratio of rise to run is negative 3 to negative 2, which comes out to be 3/2 also. So it doesn't matter which 2 points I pick on this graph to go between. If I start at one and go to the other one, where moving forward is a run of is a positive run, moving backwards is a negative run, moving up is a positive rise, and moving down is a negative rise. If I keep track of that going from any point on the graph to any other point on the graph, and then I take the ratio of that rise to run, I'll always end up with 3/2, because this graph right here has that for a slope. Now, positive slopes you associate with lines that go up as we go from left to right. And when I end up with a line that has a negative slope, that'll be a line that falls going from left to right. Also, the larger the absolute value of this number, the steeper the line is. So if I went to a graph that had a slope of 4/2, then 5/2, then 6/2, I'd be getting steeper and steeper lines like this. Okay, let's look at our next example. This time I want to find the slope of the line that goes between -3, 2, that's this point, and the point 3, -2. This time let's start with the graph and then see if we can get the slope of this line from the graph, and then see if that matches what we get when we do it algebraically. So I'm going to graph the point x = 3, y = -2, x = -3, y = 2. So I start here and I go back 3, and then I go up 2. That's the point x = -3, y = 2. Now I want to graph the point x = 3, y = -2. So I go forward 3 and then down 2. That's this point. So here's the point x = 3, y = -2, and then this is the point x = -3, y = 2. Now let me draw a line between them. So the line that goes between these 2 points right here is going to look like this. Let's see. I got that right? Okay. I want to try to do this accurately so we can get a good picture of what this line looks like. Okay, so there's the line. There's the line that goes through those 2 points. Now let's go from this point to this point with horizontal and vertical movement. So I'll start here and I'll move down 1, 2, 3, 4 units. Okay, that's a rise of -4. To get back to the line, I have to accompany that rise of -4 by a run of 1, 2, 3, 4, 5, 6. So here is a run of +6. So my slope m, which is the ratio of rise to run, is going to be -4 divided by 6. That reduces down to -2/3. So you can see here I have a line that actually falls going from left to right. The line drops as I move from left to right along the line, and it comes out to have a slope that's a negative number. Now the ratio of rise to run comes out to be -2/3. Now it doesn't mean that the rise is -2 and the run is 3. It means that the ratio of those two things comes out to be -2/3. Here I have a rise of -4 and a run of 6. That reduces down to -2/3. I can go between any 2 points on this curve, on this straight line, and get exactly the same thing. Now let's find the slope of this line algebraically. So m will also be equal to y2 minus y1 over x2 minus x1. Well, let's just start with this point and subtract the coordinates of this point. 2 subtract -2. For the difference of my y coordinates, so I subtracted in that direction. Now let's subtract in this direction with x. -3 subtract 3. Is that going to come out right? 2 plus 2 over -3 subtract 3, and that comes out to be 4 on top. -3 plus -3 is -6. I get 4 over -6, and sure enough, that's -2/3. So my geometric definition for slope and my algebraic definition for slope give me consistent results. In both cases, this line turns out to have a slope of -2/3. Let's look at our next example. This time we want to find the slope of the line that has an x-intercept 4 and a y-intercept of 2. So first of all, let me graph this line. The x-intercept is 4, so it crosses the x-axis at 4. The y-intercept is 2, so it crosses the y-axis at 2. Now I'm going to draw a line between these 2 points. And what do we get here? Something that looks about like that. Trying to be a little more accurate than I usually am with these. Okay, so it looks like going from, let's say, this point to this point, I would have a rise of -2, accompanied by a run of +4. So the slope m, which is the ratio of rise to run, is going to be negative 2 divided by 4, which is equal to negative 1/2. Now, what I want to do is the same problem algebraically. So to do it algebraically, I need the coordinates of 2 points on the graph. Well, if my x-intercept is 4, then the point 4, 0 is on the graph. If my y-intercept is 2, then the point 0, 2 is on the graph. So here's my 2 points. X equals 4, y equals 0, and x equals 0, y is equal to 2. Now from these 2 points, I can get a slope m of, well, let's see, let's take 0 and subtract 2, divided by 4 subtract 0. What do I end up with in the numerator? Negative 2, in the denominator 4, and sure enough, that comes out to be a slope of negative 1/2. So once again, you can see that my geometric results and my algebraic results are consistent with each other. This line has one and only one slope, and that slope is negative 1/2. Let's look at our next example. This time I want to find A if the line that goes through 5A and 4, 2 has a slope of 3. Well, let me use my formula for slope. M is equal to, okay, I'm going to subtract y coordinates, and let's start with A. A subtract 2 divided by 5 subtract 4. Now that slope has to come out to be equal to 3. So I end up with A minus 2 divided by 5 minus 4 is 1 is equal to 3. That's A minus 2 is equal to 3. So if I add 2 to both sides, I get A is equal to 5. So if I have this point right here, 4, 2, and another point, 5A, the way I have to fill in A so that the slope of the line that goes between these 2 points has a slope of 3, then A has to be equal to 5. That's the only thing I can fill in A with, so the line between these 2 points has a slope of 3. Next, I want to talk a little bit about parallel and perpendicular lines. So what we say is this. If we let line L1 have a slope of M1 and line L2 has a slope of M2, then L1 and L2 are parallel to each other if and only if their slopes are equal. So that's a pretty intuitive thing right there, to have parallel lines being lines that have equal slopes. So L1 and L2 are parallel if and only if their slopes are equal. This is not quite as intuitive, but it's also true. L1 is perpendicular to L2 if and only if the product of their slopes is negative 1. That is, if M1 times M2 comes out to be negative 1. Every time this happens, I get perpendicular lines, and every time I have perpendicular lines, this happens, as long as one of my lines isn't vertical. Now, usually the way you see this written, though, or the way we use it, is this. M2 is equal to negative 1 over M1. And so when I look at it this way, what I say is perpendicular lines have negative reciprocals for slope. So if one of them had a slope of 5, the other would have a slope of negative 1/5. If one of them had a slope of 3/4, the other would have a slope of negative 4/3. Now, that's not the case with parallel lines. In the case of parallel lines, the slopes are equal. So let's look at one last example that involves these formulas. We want to find y if the line through 2y squared and 1y is perpendicular to a line that has a slope of negative 1/6. So the slope of the line that goes between these 2 points, m, is going to be equal to the negative reciprocal of this, because it's perpendicular. The line that goes through these 2 points is perpendicular to a line that has a slope of negative 1/6. That means that m for the line I'm looking for has to be equal to positive 6. Now, once I've written the slope as 6, then I'm also going to use my formula right here, my algebraic formula, the difference of the y coordinates divided by the difference of the x coordinates. So I'll start here with this value of y and subtract this value of y. So I'm going to have y squared minus y, all divided by 2 minus 1. So I end up with this. 6 is equal to y squared minus y. Quadratic equation, I'll write it in standard form. 0 equals y squared minus y minus 6. When I add negative 6 to both sides, I'll factor the right side. Y minus 3, y plus 2, is that right? Inside I have negative 3y, outside 2y. They differ by negative 1y, and negative 3 times positive 2 is negative 6. I set this factor equal to 0, y comes out equal to 3. If I set this factor equal to 0, y comes out to be equal to negative 2. So I end up with 2 different values of y that will make the line that goes between this point and this point perpendicular to a line that has a slope of negative 1/6. So the slope of the line that I'm looking for must be 6, because perpendicular lines their slopes, the product of their slopes comes out to be -1. So what do I multiply -1/6 by in order to get -1? The answer is +6. Or you can say the slope of any line perpendicular to this line is going to have a negative reciprocal for slope. The negative reciprocal of -1/6 is +6. So in any case, when I solve that equation, then I end up with y = 3 and y = -2 as my two possibilities for y right here to get a line that's perpendicular to my line with a slope of -1/6. So there's a lot of different problems that you can work that involve these formulas for the slope of the line. One formula we have is algebraic, the other formula is geometric.